Ladies and gentlemen, hello. My name is Vincenzo Ciancaglini, and I am a senior threat researcher in Trend Micro's forward-looking threat research team. For those who don't know us, we are a team tasked with investigating how the technology will evolve in the next few years, and together with it, how the user habits will change, and of course, how criminals might adapt and exploit the newly offered possibilities. As many of you know, artificial intelligence has become a predominant aspect of so many fields of our industry, our society, and even our daily life. Its capabilities, thanks to the increase in hardware processing power, have grown beyond our wildest expectations, leading to applications that were simply inconceivable until a few years ago. Think about it. When we now have intelligent systems capable of driving cars, performing art, recognizing people and objects autonomously, writing poems, and even dreaming. But when we look at such wonders with the eye of a forward-looking threat researcher, we can't help but ask the questions. What is going to happen when criminals start using it? And what if they are already using it for their devious intentions? What kind of damages could they do if they broke into a legitimate AI system? These are the questions that stemmed our research on criminal and malicious uses and abuses of artificial intelligence. It's a comprehensive research done in collaboration with Europol and the United Nations Interregional Crime and Justice Research Center that aims at predicting how, in the next future, will criminals try to exploit artificial intelligence, machine learning and expert systems to help them carry out their activities, or what legitimate systems might become a target of malicious actors for them to break. Of course, this was not just a creative exercise in trying to wildly imagine every possible sci-fi scenario where artificial intelligence could be used to create a new race of super intelligent, sentient robots to take over the world. Authors much better than us already took upon themselves such endeavor. Our work needs to sit on solid ground. That is why all our predictions started by looking at what the present of possible malicious uses of AI has in place for us, to be able to see the future, what the future might hold in a more concrete manner. To better give you a clear and consistent picture of our findings, this presentation is organized into three main areas: human versus AI, which is how would malicious users try to break and abuse legitimate artificial intelligence systems; AI versus machines, or how would criminals exploit artificial intelligence to attack other systems; and AI versus humans, that is, all those techniques involving the use of artificial intelligence technologies to attack a person. In the last one, we will see two of the systems that nowadays show the most promise, which are deepfakes and AI-aided content generation. This is indeed a peculiar section, as it involves not necessarily only criminals trying to disrupt legitimate systems, but also regular citizens attempting to evade facial recognition systems. We have seen this already in this year's protests around the world, with people utilizing special makeup designs that would allow to evade state-run facial recognition systems. In this example, we can see how particular patterns painted on one's face can easily lead facial recognition systems to misplace facial landmarks. And in this example, we can see the facial recognition evasion guide that was passed around during the George Floyd protests in May 2020 in the USA. So it's tempting to assume that this trend will keep evolving throughout the years, with facial recognition systems becoming more sophisticated and people looking for new ways to evade them. Autonomous vehicles are another possible target we examined, given the vast landscape of opportunities offered by autonomous cars, delivery drones, autonomous fleets that will soon circulate our roads. Autonomous vehicles are trained to obey the law, meaning that they have machine learning models trained to recognize traffic signs and road markings and adapt their driving accordingly, And this is one of the weaknesses that can be exploited by a malicious actor wanting to hijack a vehicle or disrupt its path. For example, the Autonomous Trap 001 piece by James Brittle exploits the concept to create a trap for an autonomous car by drawing a circle of street markings. The vehicle is usually trained to be allowed to cross the dotted line, but not to cross the continuous one, making it for a very trivial trap where the car would be able to get in, but not get out. And this could be particularly effective, especially if placed in strategic areas of town, combined with a frequency jammer to disrupt any external communication. Another attack could involve toying with the vehicle image sensors, responsible for recognizing a road sign. A small piece of tape on a speed limit sign could change the digit 3, as in 35 miles per hour, into an 8. Increasing the speed limit perceived by the car, which is a mistake that in tests happen 58% of the times. Finally, smart assistants, who are already part of our daily life, can easily offer a target to malicious actors. Even today, there are several ways smart assistants can be exploited, from creating malicious custom actions resembling legitimate ones, to activating the smart assistant by exploiting an exposed connected speaker in the same room, something we investigated in our other research, The Sound of a Targeted Attack, up to the point of issuing commands using frequencies inaudible to the human ear. The consequences of such attacks can be dire if you consider that such devices are more and more put in charge of the whole automation, like we showed in another research paper of ours named Cybersecurity Risks in Complex IoT Environments. Under this category, we covered all of new AI-based technologies that could be exploited to break or overcome an adversary system. Adversary, of course, from the point of view of a malicious actor. If we look at all the technologies developed in this domain, in recent years we could organize them based on their main goal into two main groups: hacking automation and detection evasion. With the term hacking automation, we cover all new tools developed to ease and speed all hacking-related activities, let them be cracking a password or trying to break into a remote machine. For example, a tool called Deepfakes was presented at DEF CON 2017. It implements a neural network capable of crafting SQL injection strings with no information other than the target server responses, using a process of trial and error, and thereby automating the process of hacking web-based databases, or, to quote its authors, to break into web applications using a neural network, trial and error, and a frightening disregard for humankind. But it doesn't stop there. For those who don't know, Metasploit is an industry-standard penetration testing tool. It provides the user with pretty much every tool he needs to do reconnaissance, gather information on a target system, craft some malicious package exploiting the most recently discovered vulnerabilities, and deliver it to a target machine. However, with its vast choice of tools and payloads, it still leaves it to the user to find out what combination might work best on a certain target. Well, another tool called Deepfakes, which was presented at DEF CON 2018, can help exactly on that front. It interfaces directly with Metasploit, uses it to perform information gathering on a target computer, then, based on the information he gathered and its own experience from being trained using machine learning on a set of test machines, it can automatically craft the right exploit for the specific target. On the front of evading detection, on the other hand, we see how artificial intelligence can come to the aid of a malicious actor in several ways. For example, AVPass is a tool presented at Black at 2017 that allows a malicious user to infer the detection features of any given antivirus engine and craft a malicious Android binary able to escape detection. In their tests, The tool managed to achieve a 0% detection rate on VirusTotal with more than 5,000 malware samples. Or, on the topic of spam evasion, a 2015 research showed a generative grammar system able to craft spam email messages capable of evading most spam detection systems. Their tool would be able to generate a large corpus of email texts with high degree of semantic quality, use it to fuzz the anti-spam system, and adapt its generation process in order to find out what would no longer be detected by the anti-spam. More interesting, though, is the use of AI to emulate human behavior in order to evade bot detection systems. With the increasing number of botnets being used on a daily basis on social networks to spread misinformation, for example, alter reputation scores, artificially promote content, etc., and with social networks trying to fight back and identify and stop these entities, we believe this will become an even more prominent application of AI in the future. Right now, for example, one can find on sale in many underground forums a service aimed at impersonating human users on the Spotify music service. The goal is to control an army of fake users in order to generate traffic to a particular artist, the main advancement here being that each fake user can behave like a human and present music coherent preferences that would allow it to go undetected by Spotify. Here is where we look at the most interesting malicious uses of AI, aiming at fooling or attacking an actual human, the application of which generally fall under activities like social engineering, scams, phishing, and so on. This is where we find, of course, deepfakes, a topic being covered in detail in a dedicated chapter of our report. As many of you might already know, deepfakes are a new form of synthetic media generated by a neural network that is difficult for either humans or technological solutions to distinguish from an authentic one. Its most popular application, of course, is face replacement in videos, where an AI system is able to seamlessly replace the face of one person with a second one, following its mimic and expressions in the video. But while the most popular, it's not the only deepfake application. For example, it's also possible to exploit deepfakes for face reenactment, to manipulate the features of the target face to make it look like it's saying something different. The most popular legitimate use of which is resyncing someone's speech over the translations in another language. We also have face generation, that is generating convincing yet entirely synthetic images of individuals, speech synthesis, and voice cloning. From a technical point of view, deepfake works by employing a technique called an autoencoder. Basically, a first neural network called the encoder is responsible for reducing the dimensionality of a face picture to a lower latent space, and a second decoder neural network reconstructs the original face from the lower latent space data. Now, the encoder network is the same for the two faces to be swapped, while we have two distinct decoders, one for each face. So the encoder network will be trained and eventually learn to reduce both faces to their common essential features: nose, eyes, mouth, shape and positions, etc. And the two decoders are trained to reconstruct the original face from the latent features generated by the common encoder. So, say that we have face A and face B, a common encoder and two distinct decoders. What happens then if we use decoder B on the latent face generated by the encoder on face A? Well, we reconstruct face B using the facial features from face A. Hence, we swap the two. Needless to say, the potential of deepfakes' future applications especially in the perspective of them being more and more refined and difficult to identify at a glance, and with the possibility of being applied on a live video, opened the door to staggering scenarios for all that is social engineering, fake news, identity falsifications, and market manipulation. The range of possible future crimes enabled by deepfakes goes from a new form of sextortions, where you won't even need to fish for compromising pictures of victims anymore, to blatant spread of false news in order to manipulate markets or political events. Imagine if someone were to release a compromising video statement of a company CEO, only to short the stock market, the stock options right after. Video synthesis, however, is only one way a machine can impersonate a human. Voice cloning is very much another possibility, and it's available today. There are services such as Resemble.ai that can be trained with any voice and offer APIs to read a text with the target voice and pronounce with controlled expressiveness. Not only that, there's even a desktop tool released by the company founder and developed by himself when he was first researching the technology, that can be compiled on any machine and is able to perform voice feature transfer from just 5 seconds of voice samples.
There's a way to measure the acute emotional intelligence that has never gone out of style.
Things that don't work, and you just kind of barrel through it, you get through it. There's a way to measure the acute emotional intelligence that has never gone out of style.
And the other thing also was the format of the show. There's a way to measure the acute emotional intelligence that has never gone out of style.
But the scenario does not stop here. We mentioned that human-like content generation is another very real threat in the next future. On June 11, 2020, the OpenAI laboratory released a paper on their novel natural language model called GPT-3. GPT-3 stands for Generative Pre-trained Transformer, and in essence, it's a system that uses a massively trained neural network to understand and produce human-like text. GPT-3's neural network has over 175 billion hyperparameters, trained by feeding it more than 300 billion tokens, taken from sources like Common Crawl, Wikipedia, web text, books. They basically fed it the entire internet to see what would have happened. In comparison, as of today, the second biggest natural language model, Microsoft TNLG, has only 17 billion hyperparameters. But big numbers aside, you're probably wondering, okay, so what can this massive neural network do with our words and letters? Let's see some examples that selected beta testers came up with. The first and maybe less exotic application is, of course, text generation. GPT-3 is able to generate an entire page-long article able to fool most humans using a title and subtitles as few shots training samples, and only that. As a matter of fact, GPT-3 is able to reach state-of-the-art accuracy with very little training. While the model is able to perform generic tasks without any specific example, it can be fine-tuned very effectively for a specific purpose with as low as 5 or 6 samples of data. It is recent news that a GPT-3 based chatbot was able to post on the social media platform Reddit on one of the most popular sections, r-ask Reddit, and go undetected for over a week. What's even more surprising is that the only reason it rose suspicions was not because of the content of its post, but for the fact that it was posting at a rate that was physically impossible for a human to sustain. Furthermore, GPT-3 can retain state, which means that it is possible to implement things like as I said, chatbots, or text-based RPG adventures. This one here, named AI Dungeon, is an RPG that can be played online, entirely generated on the fly by the GPT-3 system. But writing a text like a human is something we can expect from such a system. However, writing a text like a very specific human is something way more interesting. And GPT-3 is able to imitate the writing style of a specific domain with its own lingo and applying that writing style even to an arbitrary text. In this example, GPT-3, trained with just 2 samples, was able to translate a very complicated legalese term sheet into plain English, choosing the appropriate words and rephrasing complicated sentences. And this, of course, doesn't stop here. When provided with examples related to a single person, the engine can, of course, imitate its specific writing style. Think of what this could mean for the future of business email compromises. Let's switch now a second from writing to reading. GPT-3 ups the game of entity extraction, being able to understand even complicated structured informations into an unstructured text. In this video, GPT-3 is able to extract from a quarterly report the financial information contained in the summary table and understand the individual voices in the table even when pasted in raw text format. In the second example, GPT-3 is able to parse the nutritional information from a label, associate an emoji, and give each ingredient a definition. Let me be clear here. The emoji and the definition of each ingredient are not queried from a database. Those are provided directly by the engine itself, who has knowledge of those entities. So, having been fed the entire internet corpus, GPT-3 is trained on code as well, let it be HTML, Python, JSX, you name it. So, it understands code and can generate it. But not only it understands code, but it can understand code and English at the same time, which means that it can translate one into another. Take this example, where the engine is used to explain in plain words what snippets of Python code actually do, getting all the way to the point where it is able to explain a recursive function. But it doesn't stop here. It is possible to describe something complex like an HTML layout and have GPT-3 generate the code for you. In this video, you can see how a very liberal description of a web page is translated into working HTML code. And when I say liberal, I mean that the user relies on similarities such as "this looks like a watermelon" that are fully understood by the system. Everything else that follows is generated without any intermediate step, and only took to train the system for this specific task were a couple of examples consisting of a layout description in English and the corresponding HTML code. So this pretty much sums up some of the most interesting applications with potentially malicious uses of artificial intelligence that we could find. I'm sure that you have plenty of questions by now, such as, Dr. V, what you just showed us looks like very powerful tools in the hand of criminals and malicious actors. Should we be worried? Excellent questions, fictional audience member. To me, it depends. Some technologies like Deepfake are indeed scaringly effective in their objective. But what always raises a good discussion is the following question. Will it actually be worth it for a criminal to adopt such technology? To go all the way down the trouble of generating, for example, a deepfake video, whereas it might turn out not to be more effective in terms of money return than a classical phishing campaign. One example that comes to mind is stock market manipulation. On paper, one could create a deepfake video with some disruptive statement from a company CEO or a state elected. Use that to create some market panic and start shorting stock options, currencies, you name it. On paper, it seems easy, but how many criminal groups in the world actually have the diverse skill set necessary to successfully pull off something like this? And how big should the reward be for them to live with the giant bullseye on their backs from every major law enforcement trying to track them down? For what it's worth, we asked these questions ourselves, and we started looking into Trend Micro's datasets to see if we could spot signs of active malware ongoing nowadays that would exploit already any form of artificial intelligence. That is, either using some known AI libraries such as PyTorch, Keras, or TensorFlow, or connect to any cloud-based artificial intelligence service offered by providers such as Amazon AWS, Microsoft Azure, Google Cloud. And so far, we couldn't find anything meaningful. That doesn't mean that it won't come in the future, so we'll keep on the lookout. So, what would it actually take for a criminal to start using these technologies? Honestly, as esteemed fictional audience member, I couldn't have asked a better question myself. First off, it's important to make a distinction of different classes of criminals, depending on their motivation. You have money-motivated criminals, classical ones, emotionally motivated criminals in case of cyberbullying or mobbing, and politics-motivated in the case of state-sponsored actors. If we focus solely on the first two categories, probably the best answer is lowering the cost of entry for certain AI technologies. Whereas, be careful, cost is intended in both monetary and knowledge terms. Right now, we are still at a stage where many new technologies such as voice cloning or deepfakes are barely coming out the POC phase and are far from being a one-click solution. What criminals would need is a point-and-click solution with an immediate return of investment. Innovation in the criminal world doesn't just happen for the sole sake of it. There needs to be an advantage. So any novelty not only has to be good, but it has to be better than what's current. For a criminal to use it, the return of investment needs to dwarf what they're actually earning with traditional extortion or phishing, plus the cost of actually retooling. This, however, doesn't necessarily apply to state-sponsored criminals that dispose of a different agenda, different motivation, higher resources, and are therefore able to employ experts to adopt new solutions. If we take back the example of the stock market manipulation, probably the only group with stakes low enough to go through with something like that would be groups operating on behalf of North Korea. Actually, one field where we think we will see AI being adopted earlier is everything that concerns faster and better analysis of stolen logs. Not only there has been promising research presented at Black Hat 2017 showing how to improve target identification in spear phishing campaigns by cross-correlating and analyzing with machine learning methods leaked datasets and logs and social media information, but this scenario offers a clear use case and several off-the-shelf tools. That is why we currently have another ongoing research on this very topic that should be out soon. For any further question, I will be available during and after this talk, which I hope you enjoyed, and I really thank you all for your attention.